We're asked to prove this trig identity, which looks pretty tricky because of the 1 minus sine theta on the right-hand side. Now, don't forget our tools are tan theta is sine over cos. That could come in useful. In fact, it's going to come in useful because you can see a tan there. And then secondly, sine squared theta plus cos squared theta is always identical to 1. So just have those two ready in your mind to use. We're going to start with the left-hand side because it tends to be easier to combine things into fractions rather than separate. And the first thing we'll do is put it over a common denominator. So times the tan theta by cos theta over cos theta. We can write it like this. Then tan theta is sine theta over cos theta. So I'm actually going to get 1 plus sine theta over cos theta. And I've found an identity, but it doesn't look anywhere near the 1 minus sine theta. So do you know what? Let's just times through top and bottom by 1 minus sine theta. Guarantee that we get that on the bottom. Because then when we expand the top, we get 1 minus sine squared theta. And it is coming together because the numerator is precisely, if you rearrange this, cos squared theta. So one of them cancels with that cos theta, and we're there. Cos theta over 1 minus sine theta, which is the right-hand side. So if we were to start with the right-hand side, we would have to do the steps in reverse, and it's just a little bit less clear, I think, to see to do that. But you might disagree. In any case, we're there. Now in B, we're asked to solve for x between 0 and 90 this equation, which looks pretty complicated, but we've got the identity. So using part A, I can take the identity and just replace all my thetas by 2x. Therefore, I will have cos 2x over 1 minus sine 2x is precisely equal to this. And then it's equal to 3 cos 2x. Okay, we're going to be solving for 2x to begin with. So actually, I'm going to change the range. We're trying to find all values of 2x between 0 and 180. Okay, I'm going to multiply through by 1 minus sine 2x. Now be really careful at this point because we're told that cos 2x can never equal 0. So actually we can just divide through by it. You might be tempted to find the solution for when cos 2x equals 0, but that would be wrong in this case. So when you divide through by it, you get 1 over here. And then 1 minus sine 2x is going to equal a third because I can divide through by 3. I can rearrange to get sine 2x equals 1 minus a third, 2/3. Okay, and then we can do inverse sine of 2/3, which gives 41.810. That is one of our solutions. But if you draw the sine graph, you'll see there's another solution here. Or you can use your cast diagram. So sine is positive here and here. So I've got my angle here. I need to do 180 minus 41.10. 138.189. So those are my solutions for 2x. Remember, we actually want to solve for x. So divide through by 2. I get 69.1 degrees for the second one. And 20.9 degrees from dividing 41.810 by 2. Well done.